All right, so prime factors. Before we do the front page, I want to skip to the second page, page 2, talk about prime numbers for a sec. Who knows what a prime number is? Can't be whatever it's called. Can't be broken down anymore, basically. All right, so excluding the number 1. So 3 and 7 are prime numbers because you cannot divide them by anything but themselves. All right. A composite number is something that can be divided or broken down, what are called factors. Okay. So 10 can be broken down into 5 and 2, right? Makes sense. Okay. What we're going to do in this first lesson is we're going to figure out all the factors or all the numbers that multiply to give, well, for 10, the factors would be 2 and 5. These are called factors. Okay. And we're going to look for prime factors, which means we keep breaking the number down until it cannot break down into anything else. So if we go back to the first page and we look at the number 15 here. So the way I do this is I make a little, it's called a tree diagram. I just ask myself, what multiplies to 15? 5 and 3. Can 5 and 3 be broken down into anything else? No. So those are the prime factors of 15. And what about 16? What multiplies to 16? And when the numbers get bigger, there's multiple ways to do this, but the end will be the same. So 8 and 2. Okay. Yes. So this 2 cannot be broken up into anything, so you just leave that. 2 is prime. 8 can be broken into 4 and 2, and then the 4 is 2 and 2. And then what you do, so 2, all these 2's are the prime factors. So we can say that 16 is the same as, and you look at the last number in each branch, 2 times 2 times 2 times 2. Or what could you write? 2 to the power of 4. So 16 is the same as 2 times 2 times 2 times 2, or 2 to the power of 4. Yeah. Okay. Here's the receipt. Let's see. Stack of books right there. Okay. Let's skip to the next page, please. Sorry, we won't jump around this much. All right. 12. Product of prime factors. Basically means write out all the prime factors. So we'll branch tree diagram. What multiplies to 12? 4 and 3. Is 3 prime? Yes, you cannot break 3 down anymore. Can you break the 4 down? Can you break the 2's down? You can't? No. You can't break it into 1 and 1. 1 times 1 is... Okay, yes. So you're done. So then you say 12. Does anybody know what product means in math? It means multiply. So it's what you multiply by. 12 is the same as what? Prime factors. Bottom of the tree. 2 times 2 times 3. And the little dot means multiply. Yeah, you could write it like this if you wanted. That's the same thing. How else could I write it with exponents? Yeah. 2 to the power of 2 because there's 2 2's times 3. You don't have to do it that way, but it's a shortened, sort of more condensed way. All right, we're going to do one more big one. So this, what we're doing is called prime factorization. Find all the primes that multiply to this number. So let's go to this number, 33,250. So you're allowed to use a calculator. You don't have to do this in your head. All right. They've already given you 1, 10. So what's the other number on the other side? 10 times what gives you 33,250? Sorry? Not 25. 3,325. That. Oh, okay. All right. Can 10 be broken down anymore? To what? 5 and 2. 3,325 can break down into, I'll give you a hint. If it ends with a 5, what can you always multiply it by? Okay, you can do 5 and 665, or you can try 25. It's a bigger number. All right. So if you divide 3325 by 25, what do you get? 133? Is that what you said? You divide by 5 or 25? Make sure my math is right. Should be 133. You can divide it. Okay, can 25 be broken down into anything else? 5 and 5. Can 133 be broken down into anything? Try 7. Yes. You keep going until you can't break anything down. So can you break down the 5s into anything? No. Can you break the 2 down? Nope, that's prime. What about the 7? What about the 19? What multiplies the 19? Other than 19 and 1? Anything? Nope. So those are all prime. So then we can say that 33250 is the same as, and you just look at the bottom of every branch. I circle it just because you don't have to. And you can say 2 times 5 times 5 times 7 times 19. That is right. You put that on a test, I will give you full marks. How could you shorten it? 2 times 5 to the power of 3 times 7 times 19. That is the prime factorization because those are all prime numbers. Okay. Does anybody have any questions about that? Same thing. Yeah. So if I said, what are the factors of 12? 2, 2, and 3. Well, yeah. I mean, you could say the factors of 12 are 4 and 3, but that doesn't really help you. All right. The prime factors are what we're going to look for, and that's what I will ask for on the test. Okay. Anything else? Okay. Congratulations. You finished your first lesson. 11, 12, A, and B, please. So what you do, how these work, if you haven't used these before, is you go to the assignment section. I'm just asking you to do 11 and 12, A and B. So just go to question 11. So you're going to do the prime factorization of those numbers and then 12, A and B as those two as well. The answers, if you go to the very back, the answers are there right where it says answer key. Okay? If you have any questions, put your hands up. I will ask you. You got 15 minutes to work on these, then we'll start in lesson number 2. Isn't this fun?